Question 10, the last one. So you've got 4 identical cans filled with water. Water comes out the tube, which shows the correct pattern. So what we're looking at is the bottom spout or hole is at increased pressure, so its water should go further than the next hole, which should go further than the next hole. So we're just looking at this distance here: bottom, then middle, then top. So A's garbage, B's garbage, C's perfect. So we can see the bottom one has gone further than this one, and that one's gone further than that one. So the answer is C. Next one, we've got a U tube containing water with a density of 1000 kilogram per meters cubed. So this is a manometer. The water levels are the same on both sides. Fine. Both ends are open to the atmosphere, and atmospheric pressure is 101,000 newtons per meter squared. So we can see it's level because that's got the same pressure as this side here. Okay, so the next part now is they're going to attach it to a gas supply. So that gas supply is going to push down on that side, and it's also going to have to push up on the atmospheric pressure. So we've got the height that it raises is 0.2, so pretty happy with that. We don't have to read the scale. We've got the density, so we're just going to have to work out the pressure. So calculate the gas supply pressure. We know P equals H rho G. So we're just going to have to plug that in and ultimately add on atmospheric pressure at the end. So P equals H rho G, 0.2, that number there, times 1000, the density, times gravity. Remember the value's 10, and we've got 2000 pascals. And then we've got to add on atmospheric pressure of 101,000. So that comes to 103,000 pascals, or newtons per meter squared. Those are the same thing. The measurement is repeated using a U tube of larger cross-sectional area. Why does the value of H not change? Well, if we're looking at P equals H rho G, there's H. There's no area in there. So it's an interesting question, shall I say. So, well, we know pressure equals H rho G. Area is just not a factor in determining height. Okay, so height is completely unaffected by area. Done. And this question's a nice 6 marker, but it wasn't done particularly well when I looked at the examiner's report. So got a cross-section boat floating in water and the same boat with a load inside. The boat floats lower in the water when there's a load inside. Yeah, we can see that. So if we were to look here, we know that this is the volume of water displaced, and we can see there's a greater volume or weight of water displaced. We know that the weight of the water, the weight of the boat is the same as the weight displaced. And we know these forces are equal, so we know weight equals upthrust because it's floating. And that's the same here, and we can see that the weight equals the upthrust. And what's happened is we have to displace more water. That is, we need a bigger height differential between the two, and that means we've got a greater pressure on the bottom. And then in terms of talking about the pressures, we know we've got atmospheric pressure on the top and we've got water pressure underneath. And the further and further and further this boat goes down, the greater the water pressure is going to be. And because of this height difference, that's what's going to lead to upthrust. Now, eventually, the boat will sink, but in this case, with the load, it's fine. So we've got 2 questions. Explain why the boat floats in water. We'll do that one first. And then why the boat floats lower in the water. And it's about really getting those keywords right. So why does the unloaded boat float? So on the upper surface, the pressure is atmospheric pressure. Pressure equals H rho G. The bottom of the boat is in water. Water is denser. So there's an increased pressure on that surface, and this causes upthrust. The boat displaces its weight in water, and the weight of the boat is equal to upthrust. So we're just saying these forces are balanced, and the upthrust is due to the pressure difference between the top and the bottom, because H changes. If I just circle that, so because that changes. Okay, so now we've just got to talk about why the boat floats lower with a load. Adding a load increases the weight of the boat. So there's a greater volume or weight of water displaced. And that's a good word to get in there. So we displace more water, which we can see in the diagram up here. This means the boat sits lower in the water. And I think that answers it quite well in terms of 6 marks. But if you want to have a good look at the mark scheme and see if there's other sentences or other parts that you'd like to include, I think that's enough to get 6. The end.